Lesson 17.2, Task 3. Solve quadratic equations by factoring. So we've got x squared plus bx plus c, that's in standard form again. We know it's a quadratic because it has an x squared term. So we're going to look at how to solve equations. All right, so it says solve quadratic equations using the zero product property. All right, this is something that's very important. You're going to see this throughout the rest of your math career. So when you get to Algebra 2, when you get to any higher level math that you're required to take, you will have to use this. So make sure that you understand it and that you definitely have this in your notes and know how to use it. So a quadratic equation, ax squared plus bx plus c equals 0, is said to be written in standard form. In this lesson, all equations have the form ax or x squared plus bx plus c equals 0. So that means the a value is 1. So this is going to be the simplest form of these equations. So you can use factoring to solve such an equation by writing it as x plus p times x plus q equals 0 and then applying the zero product property. So remember in the last two tasks, we learned to factor using x plus p times x plus q as a method. So we're going to use that again to solve equations. All right, so here's what the zero product property says. It says let a and b be real numbers or algebraic expressions. If a times b equals 0, then a equals 0 or b equals 0. Solve the equation x squared plus 5x equals 6 algebraically and check the solution. All right, so using the zero product property, we're going to solve this equation. So you're going to see how factoring makes this easier to solve. So it says, why is solving the equation x squared plus 5x minus 6 equals 0 equivalent to solving x squared plus 5x equals 6? All right, so if we have this equation to start with, and then we subtract 6 to the other side, we're just using the subtraction property here, if I can find that. Well, maybe they're wanting us to use addition. All right, so we would add the opposite. So we would add negative 6 to the other side. All right, which is the same thing as subtraction. So again, if you start with this, remember if you subtract 6 from both sides, in order for this to be equal, you have to do the same thing to both sides. And the reason we're doing that is because we want this equation to equal 0 so that we can use the zero product property. All right, so it says factor the quadratic expression. All right, so they've already done that, but let's go through the steps here and see. So we've got x squared plus 5x equals 6. And we're going to do we have an equation, so we do the same thing to both sides. So I'm going to add negative 6 to both sides. So I've got x squared plus 5x minus 6. That puts this in standard form because your exponents go in descending order. And then 6 minus 6 is 0. Once this equals 0, we can use the zero product property. So you always want to have it in this form. Now it says to factor this expression. So we're going to factor the left-hand side just like we did in the previous examples. So we're going to have x times x, what multiplies to give me negative 6 and adds to give me 5. So that's going to be 2 and 3 give me 6 and 5, but it will not give me a negative 6 here. So we're going to have to do 6 and 1. And then to get a negative, we have opposite signs, and we need a plus 5. So the bigger number gets the plus, the smaller number gets the negative. And again, it's not a bad idea to check it. X times x is x squared. Minus 1x plus 6x gives me positive 5x. 6 times negative 1 is negative 6. So again, factored form is just another way to rewrite standard form. Two different ways to rewrite it, or two different ways to write the same thing. All right, so it says, how does factoring the expression help you solve the equation? Well, now we have a product, okay? Zero product property said if you've got A times B equals 0, then A equals 0 or B equals 0. So we can say this is A and this is B, so A times B equals 0. So we can set each one equal to 0 and solve. All right, so it says apply the zero product property. So to do that, I'm going to take each factor and set it equal to 0, just like in the example here. So I'm going to have this equals 0 or this equals 0. And since this is a variable we don't know, so we always set both factors equal to 0 and solve. X plus 6 equals 0. To solve for x, I'm going to subtract 6. X equals negative 6. This one I'm going to add 1 to both sides, so x equals 1. So we're going to have two solutions, x equals negative 6 and x equals 1. All right, so they went through the same process here. They set each factor equal to 0 and solved and got negative 6 and 1. And then they plugged it back in to check to make sure it worked. So if you plug it into your original equation, and I'm going to save time because it's already been worked out here, but take negative 6, plug it in, square it, plus 5 times negative 6, and does that equal 6? Since it's an equation, they should be equal. If they do, that's a solution. Same thing with your other solution, 1. Plug it in for x. X squared plus 5 times 1 equals 6. Does that work? Yes, it does. So that shows you that your two solutions are negative 6 and positive 1. Now, to graph it, you could graph x squared plus 5x and then graph 6. So you graph the left side and then set that equal to the right side. And you can see that negative 6 and 1 are your two x values, which again are your solutions. So, how do the solutions appear? Well, they appear as your x values of your intersection points. All right, so the solutions appear on the graph of the x-intercepts. The solutions appear as points of intersections. That is true. And they do not appear as y-intercepts. All right, so state the solution. The solutions of the equation x squared plus 5x equals 6 are negative 6 and positive 1. How would the solutions of the same equation appear if you graph this? Select the phrase to complete the sentence. All right, so let's graph that real quick and see. All right, to graph this, you're going to go to y equals, and we're going to type in the equation. So x squared plus 5x minus 6. Hit graph. And now if you look, you can see 1, 2, 3, 4, 5. There's negative 6 and then plus 1. So now if you graph it all as one equation, it becomes your x-intercepts. All right, that's all for task 3. If you have any questions, let me know.